Hey kids, it's Matt here, getting connected, sharing a screen with you. So here's a new type of problem for us. The last couple have been pretty easy, pretty softball pitches. So now we're going to up the ante a little bit. Now in this one, we have a new equation. We have delta G equals G prime plus RT ln Q. Now, what are our players? Delta G, that's G under non-standard conditions, compared to delta G from a standard condition, G prime, G with the degree sign over it, plus what are the conditions doing to it? RT, in case they're gases, we have to account for that. That's what the RT does. Now they're gases, that T is going to be in Kelvin. ln Q. What's that Q? That's our equilibrium Q, our reaction quotient. And so you can see the equation up top. It's set up pretty cleanly, and I've got a nice sample problem for you here where we're going to take some solid carbon, some graphite, and we're going to throw that into water. And normally if you threw graphite into water, this would be really not very exciting at all. But we're going to do it at 700 Kelvin. And we're going to do it, as you see a little bit down towards the bottom, at relatively low pressures down here. 10 to the minus fourth, 10 to the minus fourth, very low pressure. So at low pressure and high temperature, maybe we can get this reaction to proceed, because at room temperature and atmospheric pressure, you throw graphite into water, nothing's going to happen. This is not going to be very exciting. So in this case, you've been given delta G's and our pressures and able to calculate Q. So the first thing I'd like to do is let's calculate delta G prime. That's under standard conditions, and that's just going to be a products minus reactants. So a negative 137 kilojoules. Once again, I'm getting rid of that mole because there's a 1 there, and that's okay. And just for grins and giggles, it's 0. So plus 0. Product minus, I like the simplicity of it, it's 0 again. We're not going to worry about the carbon. And the H2O we're going to worry about a little bit. So we've got a 1 in front of that. So negative 137 minus a negative 229. This seems like we're going to be just a wee bit negative here. So delta G under standard conditions, it would be, excuse me, a positive 92. I misspoke. A positive delta G. Non-spontaneous. Okay. Well, what happens now when we crank on the pressure, take the pressure way down, and take that temperature way up? So I'm halfway there. I've got the G prime. I've got RT. I need to get Q. So in this case, now we're going to do Q. And that's going to just be my product over my reactants. So in this case, I'm going to have pressure of CO times the pressure of H2 over the pressure of H2O. Hi, this is Steve. Can I help you? Hey, Joe. What's up? I'm doing good. How you doing? Another one? Another hotline director? What happened to Justin? Who did we just burn out? So this is your, well, this is, so you used to be on the board way back when I was on there. Yeah, that's what I thought. I'm like, I know this dude. So you're our hotline guy now, right? Okay, cool. All right. Well, Yeah, what am I supposed to tell people, Joe? I need a meeting. Go to the website. And do we have there are no face-to-face meetings, are there right now?